Okay, so this is the demonstration of our digital clock on the FPGA. Right now we're in current time mode, and you can tell because it's indicating AM or PM right now. Just started the clock a few seconds ago, so it's not set to anything, it's just counting up from midnight. So I'll toggle through the different modes. You can see set time indicated with an S, alarm indicated with an AL, 12 and 24-hour mode, which you can toggle with this button on the top here. So I'll put it in 24 for now to show you that the A disappears, and then I'll set the time and show you how it can display PM as well. So there's the clock still counting up from where it was before. Go into set time mode, and you toggle through the seconds, minutes, and hours with this button here. You can go up and down, and I'll leave that in 0 for what I want to set it to, but I'll go up to some number of minutes, 22 minutes let's say, and we'll toggle down to sometime in the 24-hour range. So we'll do it at 10:22 at night. Then we can hit this button to set it, and if we toggle back around, I'll put it into 12-hour mode again, and we're at 10:22 at night PM. Okay, so now I'm going to go to the alarm mode, and I'll set the alarm to 10:23, and I'll show you how our alarm function works. So we'll go to set alarm. We will move to the minutes. Oops, that's seconds. Go to the minutes. There's 23. And we gotta move this to 22:23. Okay, so that's the alarm set now. Now down here in the bottom corner, this is our alarm suppressor. Currently it's up, meaning the alarm won't go off. So we'll turn it down and push it back to there, all right? So it'll go off when the time hits. So we're gonna go back to the regular time, and in just a few seconds here, we should see the RGB lights go off for our alarm. There we go. And these will go off for 60 seconds until the hours and minutes no longer matches, or if we suppress it by sliding that up. And we'll just keep rolling no matter what. Okay, this is our overall wrapper for our digital clock. As you can see, we have all of our inputs for buttons and outputs for RGB and 7-segment displays. We have all of our modules, top modules invoked in this statement for our current time, our set alarm, and our set format. And then all 4 of these put out a 40-bit signal to a MUX that is controlled by a state selector to tell the 8-segment displays which of the 4 signals it will put out to the board. If the alarm goes off, it then will show an RGB show of flashing lights. If we go to our state selector module, it passes in a mode select and passes out a 2-bit register for the 4 states. Basically, it will have 8 different states that it can move into, 2 for each of the modes. And depending on what state it's in, it will cycle around to the next state and pass out the correct mode as applicable as the state selector button is pressed.
So here we have our set time module, which takes in a 17-bit core time array. This value can hold 86,400 values, which represent the number of seconds in a day. And that, in addition to inputs we use in our ALU to manipulate and output another 17-bit time. Those values are passed into our core time decoder, which parses the 17 bits into hours, minutes, and seconds of 10 bits each. So here we have our core time decoder, which again takes in 17 bits, and in this always block we see that it uses modular division to separate the bits into the number of hours, number of minutes, and number of seconds. We then use those 3 values in our decimal converter, which converts binary to binary coded decimal, which is used in our 7-segment display.
Okay, now we're going to talk about our successes and difficulties we had with this lab. John, you want to go ahead with successes?
So one of our successes was creating our modules independently and testing them independently via test benches, as well as pushing them to the FPGA board. After that, we successively combine the different modules into larger and larger components so that in the end we had one working module.
I agree. The biggest difficulty I think we ran into was, even though we plotted our original organization of the hierarchy of the different modules we were going to have, our core time, which is just one value that counted seconds up throughout the day, we originally had as a relatively high module, and it took us a while to figure out that it had to be a relatively low-level module, so all the other modules could reference that core time. And so we could set it or compare it to the alarm module, or even to the 12/24 hour module could reference it to know what value to put out to the board. But once we figured that out, we were able to combine our modules pretty successfully, and everything worked okay from there.